Good morning, 𝗕𝗲𝗲𝗶. Good morning, grade 6 learners. Welcome to our radio-based instruction in Mathematics 6 in collaboration with Radio Z-eskwela and Z-Radio 88.5. Siguradong kuyaw, siguradong lingaw. This is your teacher in Mathematics 6, Teacher Joseph Babag, bringing you another fun and exciting math amazing lessons and activities today. So, make yourselves comfortable and make sure that you can hear this broadcast clearly. Please prepare also all the necessary materials like your module, notebook, and ballpen. As we start our lesson, be sure to listen attentively and follow all the instructions in every activity. At the end of the session, you are expected to achieve the following objectives. Find the surface area of cubes, prisms, pyramids, cylinders, cones, and spheres. Solves word problem involving measurement of surface area. So, are you ready to learn another math amazing lesson today? Very good! Prior to our lessons, can you recall what are the properties and examples of solid figures? Well, let us activate your prior knowledge about our topic today by answering our first activity. In your notebook, write only the letter of the correct answer. Number 1. Solid figures are three-dimensional objects having length, width, and height. Again, solid figures are three-dimensional objects having length, width, and height. A. True. B. False. C. Maybe. Number 2. Prisms, pyramids, cylinders, spheres are example of space figures. Again, prisms, pyramids, cylinders, and spheres are example of space figures. A. Is it true? B. False? Or letter C. Maybe. Number 3. What type of solid figure that has two circular bases that are congruent and parallel? What type of solid figure that has two circular bases that are congruent and parallel? A. Is it cylinder? B. Sphere? C. Prism? Next number 4. Blank is a curved surface of points that are all the same distance from the center. Blank is a curved surface of points that are all the same distance from the center. A. Is it cylinder? B. A cone? Or letter C. A sphere? For the last number 5, which of the following composed of two triangular bases and three rectangular lateral faces? Again, which of the following composed of two triangular bases and three rectangular lateral faces? A. Is it rectangular prism? B. A triangular prism? Or letter C. A pentagonal prism? Time's up! Let's check your answers. For item number 1, solid figures are three-dimensional objects having length, width, and height. What do you think is the answer? If your answer is letter A, well, you are correct. For item number 2, prisms, pyramids, cylinders, spheres are example of space figures. What is your answer? If your answer is letter A, well, you are correct. And number 3, what type of solid figures that has two circular bases that are congruent and parallel? Well, the answer is letter A, cylinder. Number 4, blank is a curved surface of points that are all of the same distance from the center. What do you think is the answer? Very good. The answer is letter C, a sphere. And for the last item, which of the following composed of 2 triangular bases and 3 rectangular lateral faces? If your answer is letter B, well, you got it right. It's triangular prism. And for our second activity, identify the solid figure that is represented by real objects. Ready? Number 1, ice cream cone. Number 2, an orange. Number 3, a showbox. And number 4, a coin. Number 5, a soccer ball. Number 6, a dice. Number 7, a can of milk. Number 8, a globe. Number 9, a box of chocolate. And number 10, water tank. Ballpens up, let's see if you get the correct answers. For a solid figure number 1, ice cream cone, what is your answer? Very good, the answer is cone. For number 2, a solid figure orange represents, very good, a sphere. Number 3, a solid figure showbox represents, correct, it's rectangular prism. Number 4, a coin, correct, it's cylinder. And for number 5, a soccer ball, you got it right, it's sphere. And for number 6, a dice, very good, it's cube. And for number 7, a can of milk, correct, it's cylinder. Number 8, a globe. If your answer is sphere, then you are correct. Number 9, a box of chocolate. If your answer is triangular prism or rectangular prism, well, you are correct. And for the last item, water tank, very good, it's cylinder. Now, take a look around. Solid figures are everywhere around us. What this means is that solid figures have a width, a depth, and a height. For example, look at your cell phone, computer, television, radio, or whatever else you are using to view or listen our lesson. This may make you think that solid figures are probably quite common in the environment around us. And you are right. Since solid figures are three-dimensional objects, meaning they take up space in our universe. Let's start the concrete discussion of our new lesson today by defining surface area that solid figures take up. What does surface area means? Yes, surface area is the sum of the areas of the base and the lateral faces of a space or solid figure. And one way to find the surface area of a solid figure is to find the area of its nets. You can measure area in square units such as centimeter squared, feet squared, meter squared, and other units. But what are the formulas in finding the surface area of cubes, prisms, pyramids, cylinders, cones, and spheres? When you find the surface area of a prism, it is a good idea to find the lateral area first. Yes, the lateral area of a prism is the product of the perimeter of the base and height, and that is lateral area equals PH, or lateral area equals perimeter times height. Thus, the surface area of a prism is the sum of the lateral and the area of the two bases, or surface area equals lateral area plus 2b. Now, if we want to know the surface area of a cylinder, what formula we are going to use? For the surface area of a cylinder, we need to find first the lateral area. The lateral area of a cylinder is a product of the circumferences of the base and the height of the cylinder. That is, lateral area equals 2 pi RH, or lateral area equals 2 pi times radius times height. Thus, the surface area of a cylinder is the sum of the lateral area and the areas of the two bases, or surface area equals lateral area plus 2b. But how about the surface area of a pyramid? Yes, the surface area of a pyramid is the sum of the lateral area and the area of the base. Again, when we say surface area of a pyramid, it is the sum of the lateral area and the area of the base. And to find the surface area of a pyramid, we need to find the lateral area and the area of the base. Then, we are going to add. Therefore, we have surface area equals lateral area plus b, or base. Next is the surface area of a cone. How to get the surface area of this solid figure? Yes, the surface area of the cone is the sum of the lateral area and the area of its base. Thus, we have surface area equals pi rs plus pi r squared. But how about the surface area of a sphere? Well, the area of the circle that contains the center of the sphere is pi r squared. And to get the surface area of a sphere with radius, or r, we will use this formula. And that formula is surface area equals 4 pi r squared. Now let's consider these examples. For example number 1, find the surface area of the triangular prism. The shape of the base is a triangle with sides 12 meters, 7 meters, and 10 meters. The height of the prism is 14 meters. Now let's try to understand the solution. For step 1, find the lateral area using the formula. We have lateral area equals PH, or perimeter times height. Now we have the perimeter, which is 12 plus 7 plus 100 multiplied by the height, which is 14. Then we get 406 meters squared. Since we have the lateral area, the next thing that we need to do is to find the surface area by using this formula. Surface area equals lateral area plus 2b. Then we get lateral area plus 2, open parenthesis, 1/2 times base times height. Remember that our base is a triangle. So, to find the base, let's consider letter B or the base is equal to 1/2 times B or the base times height, where B is the base and H is the height of the triangle. So we have 406 plus 2, open parenthesis, 1/2 times 12 times 4. So we multiplied 2 by 1/2 times 12 times 4. Then we get 48. Next is we add 48 and 406 and we have 454 meters squared. This means that the surface of the triangular prism is 454 meters squared. Now let's proceed to our second example. Find the surface area of the can of milk with a radius of 1.5 centimeter and a height of 4 centimeter. Use pi, which is equals to 3.14. Now let's proceed to the solution. For step 1, we need to find the lateral area first, and we are going to use the formula for lateral area, which is lateral area equals 2 pi RH. Now we have 2 times the value of pi, which is 3.14, multiplied by 1.5 times 4. Then we get 37.68 centimeters squared. Now we have the lateral area, so we have to proceed to our step 2, which is finding the surface area. We have surface area equals lateral area plus 2b. Now we have lateral area plus 2 pi r squared. The lateral area is 37.68 plus 2 and the value of pi, which is 3.14 multiplied by 1.5 squared. Now we have 51.81 centimeters squared. This means that the surface area of the can is 51.81 centimeters squared. And for the third example, find the surface area of the right square pyramid with a base of 25 meters and a height of 32 meters. Now let's proceed to the solution. For step 1, we need to find the lateral area. There are 4 congruent lateral faces. Now let's find the areas of the triangles using lateral area equals 4, open parenthesis, 1/2 times base times height and close parenthesis. So we have lateral area equals 4 times 1/2 multiplied by our base, which is 25, times 32, which is the height. So, the lateral area is 1,600 meters squared. And for our step 2, find the surface area using the formula surface area equals lateral area plus b or the base. Take note that the base is a square. So, we need to solve this by using base equals s squared or s times s. Then we get 25 times 25. Then our base is 625 meters squared. So, the area of the base is 625 meters squared. So we have surface area equals lateral area plus b. Our lateral area is 1,600 and our base is 625. We add these numbers, then we get the surface area equals 2,225 meters squared. Thus, the surface area of the pyramid is 2,225 meters squared. And for our fourth example, find the surface area of the ice cream cone with a radius of 2 cm and a slant height of 6 cm. Use pi, which is 3.14. For step 1, you are going to find the lateral area by using the formula lateral area equals pi rs. Now we have lateral area equals 3.14, which is the value of pi, times 2, which is our radius, and 6, which is the slant height. Now we have 2 times 6, we have 12. So we multiply 3.14 by 12, then we get the lateral area of 37.68 centimeter square. Now let's proceed to the step 2. Find the surface area and use the formula surface area equals lateral area plus b. Now we have surface area equals lateral area plus b. Surface area equals 37.68 plus 3.14 multiplied by 2 squared. 3.14 multiplied by 4, the answer is 12.56. Now we have 37.68 plus 12.56. Then we get surface area equals 50.24 centimeters squared. This means that the surface area of the cone is 50.24 centimeters squared. For example number 5. Find the surface area of the basketball with a radius of 4.89 decimeter and round your answer to the nearest tenths. Now try to observe the solution. We need to use the formula surface area equals 4 pi r squared to find the surface area. Now we have surface area equals 4 pi r squared. We have 4 multiplied by 3.14, which is the value of pi, times 4.89 squared, which is the radius. Surface area equals 4 times 3.14 multiplied by 23.9121. Then we get 4 times 75.083994. Then we get the answer 300.335976 or 300.3. This means that the surface area of the basketball is approximately 300.3 decimeter square. I hope you get it. Do you have any clarifications? Feel free to ask, but as for now, we will take a short break. When we come back, let us solve problems involving surface area or different solid figures. So, don't go away, stay tuned so that you won't miss any significant part of our lesson. I will be right back.
The Radyo Z-eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
And we are back! Sit back and relax as we continue our lesson discussion. Just a few minutes ago, you have learned the different formulas in finding the surface area of different space figures. This time, we will be applying all that you have learned by solving word problems involving measurement of surface area. So, here we go! You will be solving the word problem. Can you recall the steps in solving word problems? That's great! In solving word problems, we need to follow the following steps such as understand the problem, next, plan the problem, then, solve the problem, and lastly is looking back or checking of your answer. Now, are you ready? Good! So, let's start. In your notebook, take note the given problem, then solve. For problem number 1, John works in a company that makes tents. His boss assigned him to design tents for mountaineers. He needs to keep them light. To decide what fabrics are acceptable to mountaineers, he needs to know the amount of fabric it takes to construct a rectangular pyramid tent with 4 meters by 1.5 meter base and a height of 3 meters. How much fabric is required to construct this tent? Now let's solve this problem by using the steps in solving the problem. Now we have first, understand. What is asked in the problem? Very good. The measure of fabric required to construct a tent. And what are the given? Yes, the given are a rectangular pyramid with 4 meters by 1.5 meter base and height of 3 meters. The next thing that we need to do is to plan. Which formula or formulas shall we use to solve the problem? Very good! We are going to use the formula surface area equals lateral area plus base to find the surface area of the rectangular pyramid. Take note, since the shape of the tent is a rectangular pyramid, there are 4 faces with different measurements. Left and right faces has the same measure. Front and back faces has the same measure too. Considering the formula, surface area equals lateral area plus base, where surface area equals the lateral area, which is 2 open parenthesis 1/2 times width times height, which is our left and right faces, plus 2 open parenthesis 1/2 times length times height, which is our front and back, plus length times width, which is our base, and the area of the rectangular base. Now let's proceed to our solution. We have surface area equals 2 open parenthesis 1/2 times width times height close parenthesis plus 2 open parenthesis 1/2 times length times height close parenthesis plus length times width. Now we have 2 open parenthesis 1/2 times 1.5, which is our width, multiplied by 3, which is our height, plus 2 open parenthesis 1/2 times 4, which is our length, multiplied by 3, which is the value of the height, plus 4, which is our length of the base, multiplied by 1.5, which is our width. Remember that we need to solve first the numbers inside the parentheses. Now we have 1/2 times 1.5 times 3, we get 2.25. Next, we have 1/2 times 4 times 3, we get 6. And for the length multiplied by width, we have 4 times 1.5, then we have 6. So we get 2 times 2.25, we have 4.5, plus 2 times 6, we have 12, added to 6. Now we have 4.5 plus 12 plus 6, then we have the surface area equals 22.5 meters squared. This means that the amount of fabric needed to construct a rectangular pyramid tent is 22.5 meters squared. And for the last step in solving the problem, of course, we need to check our solution. Go back to our computation. Let's check if the given dimensions are properly substituted to the formula. Check also the flow of the computation. Now let's continue to our second problem. For problem number 2, suppose you want to produce basketballs with 4.89 decimeter radius. What is the least amount of rubber you would need if you want to produce 20 basketballs? Use pi equals 3.14. Now let's start by understanding the problem. What is asked? Correct. The problem asks for the amount of rubber needed to produce 20 basketballs. And what are the given facts? Correct. The given facts are radius of 4.89 decimeters. Now, let us plan. Which formula or formulas shall we use to solve the problem? Very good observations. The ball is a sphere. So we need to use the formula surface area equals 4 pi r squared to find the surface area of the ball. Now let's do the solution of the problem. Surface area equals 4 pi r squared. We have 4 times 3.14, which is the value of pi, times 4.89 squared, which is the radius. Then we get 4 times 3.14 times 23.9121. Next is we multiply 4 by 3.14, then we have 12.56. Multiply this by 23.9121. Then we get the surface area equals 300.335976 decimeters squared. In this case, you need to produce 20 basketballs, so we need to multiply the surface area 300.335976 by 20. Then we get 6006.71952 or 6006.7 square decimeters. This means that you need at least 6006.7 square decimeters of rubber for 20 balls. Lastly, check your answer. Go back to your computation, check if the given dimensions are properly substituted to the formula, and check also the flow of the computations. For our next problem, problem number 3, about how much metal was used to make a tuna can with a diameter of 12 cm and height of 5 cm. Again, about how much metal was used to make a tuna can with a diameter of 12 cm and a height of 5 cm. Now let's understand the problem. What is asked? Correct. The amount of metal used for the tuna can. And what are the given facts in the problem? Yes, the tuna can has a diameter of 12 cm and height of 5 cm. Next, we need to plan for the problem. Which formula shall we use to solve the problem? Very good. The can of tuna is a cylinder. This means that we need to use the formula surface area equals lateral area plus 2b, or surface area equals 2 pi RH plus 2 pi r squared. Since a diameter is equal to 2 times the radius, we have a 6 cm radius. Next, let us solve by using the formula. Surface area equals 2 pi RH plus 2 pi r squared. Now we have 2 times 3.14, which is the value of pi, times 6, which is the radius, and height of 5, plus 2 multiplied by 3.14, which is the value of pi, times the radius 6 squared. Next, we have 2 times 3.14 times 30, which is the product of 6 times 5, plus 2 times 3.14 times 36. Then we have 2 times 94.2, which is the product of 3.14 multiplied by 30, plus 2 times 113.04, which is the product of 3.14 multiplied by 36. Then we get 2 times 94.2 equals 188.4, plus the product of 2 times 113.04, which is 226.08. Now we have 188.4 plus 226.08. The answer is surface area equals 414.48 centimeters squared. This means that the amount of metal used for the tuna can is 414.48 centimeters squared. Lastly, check your answer. Go back to your computation. Check if the given dimensions are properly substituted to the formula, and check also the flow of the computation. At this moment, since you already know the formulas and steps in solving problems involving measurement of solid figures, let us try another activity for you to master the knowledge of our lesson today. In your notebook, solve each problem, and you can draw an illustration if necessary. Are you ready? Now, let's start. Number 1. Jason is wrapping a present. The box he is using is a rectangular prism with a length of 18 inches, a width of 10 inches, and a height of 4 inches. Find how many square inches of paper he needs to wrap the entire box. Again, Jason is wrapping a present. The box he is using is a rectangular prism with a height of 18 inches, a width of 10 inches, and a height of 4 inches. Find how many square inches of paper he needs to wrap the entire box. Number 2. A certain music box has the shape of a cube. Each side of the music box is 15 cm long. What is the surface area of the box? Again, a certain music box has the shape of a cube. Each side of the music box is 15 centimeters long. What do you think is the surface area of the box? Number 3. A salt container has the shape of a cylinder. The radius of the container is 1.5 inches and the height of 6 inches. Find the surface area of the container. Again, a salt container has the shape of a cylinder. The radius of the container is 1.5 inches and the height of 6 inches. Find the surface area of the container. Use pi equals 3.14. Number 4. A cylinder-shaped water pitcher has a radius of 5 inches and a height of 12.5 inches. Find the surface area of the pitcher. Again, a cylinder-shaped water pitcher has a radius of 5 inches and a height of 12.5 inches. Find the surface area of the pitcher. And for the last number 5, find the amount of tin needed to make a milk tin can that has a radius of 2.5 centimeter and a height of 5 centimeter. Again, find the amount of tin needed to make a milk tin can that has a radius of 2.5 centimeter and a height of 5 centimeter. Are you all done? Good! We will check your work now. For problem number 1, Jason is wrapping a present. The box he is using is a rectangular prism with a length of 18 inches, a width of 10 inches, and a height of 4 inches. How many square inches of paper he needs to wrap the entire box? What is your answer? If your answer is 584 square inches, then your answer is correct. For problem number 2, a certain music box has the shape of a cube. Each side of the music box is 15 centimeters long. What is the surface area of the box? Very good. The answer is 1,350 centimeters square. For problem number 3, a salt container has the shape of a cylinder. The radius of the container is 1.5 inches and the height of 6 inches. What do you think is the surface area of the container? Well, if your answer is 70.64 square inches, then you got the correct answer. And for the 4th problem, a cylinder-shaped water pitcher has a radius of 5 inches and a height of 12.5 inches. Find the surface area of the pitcher. Yes, the correct answer is 549.5 square inches. And for the last problem, number 5, find the amount of tin needed to make a milk tin can that has a radius of 2.5 centimeter and a height of 5 centimeter. Well, if your answer is 117.75 centimeters squared, then you got the correct answer. Great! That was an awesome job. For now, just relax for a while, and I'll be back very soon. If you have any clarifications about our topic, feel free to ask on comment sections or in our text hotline, for we are going to entertain it later on.
The 𝗔𝗲𝗃𝗲𝗃 program of the Division of Davao de Oro is being brought to you by 𝗓𝗏𝗏 Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, 𝗕𝗯𝗴𝗃𝗃𝗵 Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Maze Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
I am back, so keep on listening too. Now, let us have a brief summary of our subject matter today. What are the formulas in finding the surface area of solid figures? Always remember that in finding the surface area of solid figures like cubes, prisms, pyramids, cylinders, cones, and spheres, remember to use these formulas. To find the surface area of a prism, the formula is surface area equals lateral area plus 2b. And to find the surface area of a cylinder, use the formula surface area equals lateral area plus 2b. And in finding the surface area of a pyramid, we're going to use the formula surface area equals lateral area plus b. And in finding the surface area of a cone, the formula is surface area equals pi rs plus pi r squared. And to find the surface area of a sphere, the formula is surface area equals 4 pi r squared. And what are the steps in solving word problems involving measurement of surface area? Yes, in solving word problems involving measurement of surface area, remember the following steps. 1. Understand the problem. 2. Plan the problem. Number 3. Solve for the problem. Lastly, is looking back or checking of your answers. You are doing great today. Congratulations for completing all the tasks. That's all for now. Thank you for listening. This is your teacher in Mathematics 6 signing off with the saying, it's more fun to learn math techniques. Goodbye!
𝗧𝗲𝗃𝗲𝗃 Executive and Technical Working Committee. The school's Division Superintendent, Euphemia T. Gamutin Seso 5. Assistant Schools Division Superintendent, Dr. Romel R. Handayan. Curriculum Implementation Division OIC Chief, Dr. Arlene B. Lim. School Governance and Operations Division, Dr. Ruben J. Riponte. Program Director, Dr. Arlene B. Lim. Assistant Program Director, Noemi P. Canales. Members, Cecilia Morales, Dr. Hilda A. Opeña, Dr. Eldecris B. Calzadora, Dr. Dexter A. Siquinia, Nohara O. Pinute, Dr. Grace D. Pontillas, Dr. Renato N. Pakpakin, Dr. Andy P. Cabodok, Juanito Lapiceros, Engineer Norberto S. Manlangit, Ryan Villanueva, Jomar M. Dumupoy, Bob Daylan S. Milabat, Medard D. Apit, and Paz Eugenia Villusino. Technical Working Committee, Production and Communications, Lorely E. Quijano, Given G. Hinampas, Judiland T. Yu, Donna D. T. Bolifer, Mary Rose N. Resma, Riwen C. Manuel, Irene Lea C. Manguhon, and Bessie Aya N. Banyes. Social Media and Packaging Team, Christian Anhara L. Martesio, William R. Ranara, Joan T. Iscoton, Roberto S. Acusar Jr., May B. Istaniol, Richard H. Arellano, Ralph A. Tabanyag, Angelo C. Gutierrez Jr., Jade Karen R. Arais, Eliza May Garsuta, Sedi S. Caballero, and Jane S. Caballero. Sa Radyo Z-eskwela, siguradong masaya. Right and only here at Z Radio 88.5, ang istasyong siguradong lingaw, siguradong kuyaw.